Hey everyone. As I go through the week on my different tasks and things, a lot of things come to mind to talk about for the podcast. And depending on what the weeks looked like, I may or may not remember them by the time I get to the podcast. So this week, let's just do a little recap of some of the stuff going on. One of the things going on right now is I've got the larger actuators out for doing the 4 panel rig. Now, if you're familiar with these standing desks, that's what an actuator is. It's the piece on the side that raises and lowers the desk. And the first set that I've got out with the small panel one is rated for 330 pounds each. There's a pair on that. This one I believe is rated at 200 pounds each, which is more than is necessary to lever this up and down. But they're not really an outdoor type of thing. Now, they've got nice connectors to them. The connectors close over themselves and things, but I'm going to take compression tape to them, I think, and go over that once I get it mounted up. So the way this is going to work, both of them, is they're going to have a electrical box. Now, the electrical box that I got this time for the bigger set of panels is like one of those ones you'll see for outside for doing outdoor lights around Christmas time and things, where they're made for electrical wire coming in. And the reason I can get away with that here is the controller for this is a regular 120 AC. So I'll bring an extension cord up from another box that I've got down below that has a strip to it. And from that, I will bring up an extension cord and plug it into the box. The rubber will seal around the box so that it'll have a good seal to it, but inside the box will be the 2 bits to this one. One is the power supply to convert the power down from the 120, and the other is the actual controller itself, which is wireless. When I'm done with both of these, in theory from the house, because it's right outside my window, I will be able to raise and lower these things no matter what the weather. Right? I can just do it from here and not have to worry about going outside. I can, come the winter time, because the panels are almost horizontal. Almost vertical. Come winter time, I don't have to worry about the snow as much. As soon as the sun hits the panels start to heat up, the snow falls off. So it's unlike what you would see on a roof because the angle's different. But these aren't quite going to be vertical this year, so we'll have to see. May have to get out there and do a little work on them. We'll see, but I can be a little bit more proactive on setting them up and down. The downside to both of these, however, is going to be, how do I know what angle they're at? Now, both of them have remote controllers. The one for the 330s is a 12 volt. Doesn't have its step down transformer or anything else to it, so I got to run a 12 volt line out to that. The other one takes the 120, so that makes it easier because I've already got a 120 line outside. But once I get those set up, how do I know what the angle of the panels are from basically the back side? They're outside a window. I can see the panels, but I can't see the numbers on them. So I kind of wonder if there isn't some way that I could put inside both of these weatherproof boxes, some little Raspberry Pi or some other little device that I could put in there that would be able to tell me the angle of the box. It would have to be wireless, so we get it back, and it would have to be for both boxes, for both panels because they move independently. But we'll have to see. There's probably a nice analog method that I could use that would be unobtrusive, that would allow me to see what it is. Something simple like a pole sticking out that I can look at an angle chart next to it, or just put marks for where I want it to be during certain times of the year and just move it to those marks. We'll have to see what I can do for that. In theory, that would work. But again, it's what's going to hold up long term. Anything I put outside like that is going to kind of be in the way, and so it's not going to be as advantageous as if, obviously, if it would tell me what the angles are for everything. But that's what's going on with that. The hot water tank, still need to work on getting that put up. Got the extra hardware for it because unlike a hot water tank, where you usually see just the lines coming in, you got the drain line at the bottom, you have to descale these tankless ones. And that means running vinegar through them or something similar once or twice a year. And in order to do that, you really have to have some way of pumping that in and pulling it out, but you got your lines connected up. So there has to be a way to put another line in, cut your water off, and pump in what you want through the one side, turn the outlet off on the other side, and have it pump out. Although you could run it through your lines in the house, I wouldn't recommend it because depending on the run that you've got, you may have to put a lot of water through it to clean it out. But again, when you get done, you're going to have to go through and run water through the system anyway, just to make sure that you don't have any air in the system. Tankless systems do not work well. If there's air in there, it can be damaging to the tank because it's trying to heat up something that doesn't heat up like water does, and it can burn out the elements in there. Got the place for it. I've still got to pull out the old tank. The old tank's probably full of sediment. It's a 30 or 40 gallon tank to it. It's probably going to be heavy as heck. I got most of the water out, I think, at this point. I think it's sediment basically at this point, and that's why I had problems getting the water out. It was just trying to drip its way through the sediment. So once we get that pulled out, then I can get back in there and set up the framing that I want to put together for the tank. The system, it sits up, so the both of the output and input are pointed downward, and then it's got to be wired up. So we're getting a little bit closer to that one. My kitchen system had a tank to it years ago. Haven't run hot water in the kitchen in a while. Again, it's a small one that was out there. It's got a cold water line coming in. I need to pull out the tank for that one. Unfortunately, the way the kitchen was designed, I have to pull out the stove in order to get to the water tank, so I can pull the water tank out, and then I can frame up a new position for one of the small tankless units. All right. Hopefully it's a 120 that I can find that'll fit in there. We'll see. I don't remember what the other water heater was in there. I'll have to see what the rating was on that. So I might be able to just reuse that circuit to put the tankless in there and go from there. This other tankless unit wants 3 40 amp fuses, so obviously I can't reuse the circuit that the old water heater was on. Kind of makes me wonder about the old water heater, though, because the old water heater was a simple 240 running off a straight 30 amp 2 poles, so I'm a little concerned about how they had that thing hooked up in the first place. Nevertheless, putting a small tankless in for kitchen should be more than enough to generate hot water to do dishes, right? In theory, if you wanted to, and you could do it around the house, you could get small 120s and put them in around any place you needed hot water. So if you had like a bathroom and a kitchen, you could do small units in for that, and then you could just use a larger unit, but not as large, to handle your showers and baths. And it kind of makes me wonder if that isn't a better approach than what a lot of people, I believe, do, which is just try to replace their hot water heater, right? You've got a hot water heater. Now, we didn't here because the kitchen had its own system to it. So I kind of wonder if you'd be better off breaking your house down into little pieces, because when you think about it, the system that you've got to run your shower or your bath needs to be cranking out more heat. than the other ones do, basically for the amount of water that's going to go through them. So if you've got a smaller unit and you've got less of a water usage for that, like just doing the dishes, I think you get away with a smaller unit. And if you get away with a smaller unit there, then you're not using the big unit and pumping all that power into that. Additionally, because in my case, the kitchen is approximately 40 feet, I believe, away from my where the water tank was. So that's probably why they put the second water heater in. Or it could just be that they had it originally designed that small water heater was supposed to handle the entire house. I'm not sure. It was just a shower and a bath that was in there, and 2 bathroom sinks and a kitchen sink. So it might be they were thinking they could get away with the one small one. This original water heater wasn't there. We put that new water heater in later on. So I'm thinking that might be how they thought it was going to work with just the small one. But if you take it and reverse that, all right, so you don't have a 40-foot run of pipe that can cool off your water temperature, and you're just going literally from underneath the sink. Think of it as kind of like the location of a garbage disposal. You've got your little tank right there, and it's heating the water that's coming down the pipe, and it's just dropping it to you right there. There's no opportunity for it to cool off. And I don't know what they use, but because I haven't looked at the small ones yet, but I'm assuming they use less electricity, have a smaller circuit. Maybe they're a 240, but something to get away with a 15 amp or something on it. And that would allow you to just have a little hot water heater right by your source. So if you had a little hot water heater there and a little hot water heater in your bathroom to handle your sinks, you lose a little space, granted, because it's going to take up a little space underneath both of those sinks. But at the same time, you now have hot water right there, a smaller unit to handle it, so that you're not dealing with the big unit pumping pumping the house at this point. And then you're only using the big unit when you need it for showers and baths. So if that's the case, and you've got let's say a family of 4, you got 4 showers during the day, and that unit's just down for the rest of the time. Your dishwasher's running, or you're washing your dishes, completely different unit. Smaller unit, less power. You get ready for bed, you're in the bathroom, brushing your teeth and things like that. Again, smaller unit, completely different set of power. So I wonder if that's not a better way to design houses using tankless systems than trying to think of just, well, we'll get a really big unit to handle the house. What if we broke it down a little bit? Kind of like I did with the electrical. Certain parts of my house need more power, so I've got the big unit to kind of feed everybody. But I've got a 2 kilowatt unit here that does a great job of handling my cooking, for example, handling my making a pot of coffee or hot water for tea. So breaking it down might be a better way of looking at things. Not a plumber or an electrician or an architect of a house, but I kind of wonder if it doesn't make more sense to do things more modular. We did it here. I think this was something that my folks did with the house. I think we did the big hot water tank here just because we were having we were having issues with the shower and the bath. So we put a bigger tank up so that could handle taking baths, because the other tank, being at this point 30 feet away and being much smaller, wasn't putting out enough hot water to do that. So that's a possibility. So something to keep in mind. But those are the 2 big projects going on right now. And that's what I got for you guys this week. I will talk to you all next week.